May 4th, 2007, 9:45 p.m., Greensburg, Kansas. A tornado nearly 2 miles wide is about to swallow an entire town in less than 5 minutes. Winds near 205 miles per hour will tear homes from their foundations, crush businesses into splinters, and leave 95% of Greensburg destroyed. By the end of the night, 11 people will be dead, more than 60 will be injured, and this storm will become the first EF5 tornado ever rated under the newly introduced enhanced Fujita scale. But the numbers are only the surface of the horror. What made Greensburg unforgettable was not just the violence, it was the size. This tornado was so wide, so perfectly placed, that it did not clip a neighborhood or tear through one side of town. It consumed almost everything. Street by street, block by block, Greensburg was not merely damaged, it was nearly erased. Greensburg sat in south-central Kansas, a small plains town with a population of roughly 1,500 people. It was the kind of place where distances felt open, the skyline felt low, and life moved at the pace of a close community. In physical terms, the town stretched only about 2.2 miles across. That detail matters, because the tornado that struck it reached a peak width of roughly 1.7 to nearly 2 miles. In other words, the circulation was almost as wide as the town itself. Most tornado disasters leave pockets of survival outside the core path. Greensburg had almost no such margin. When the storm arrived, nearly every home, every street, every business, and every family in town lay inside the zone of impact. What makes this event even more astonishing is that May 4th was not expected to be the worst severe weather day of the outbreak. Meteorologists were watching a strong upper-level trough moving into the United States, but the system appeared to be lagging. The expectation was that it would mature later, making May 5th the more dangerous day. Instead, the atmosphere accelerated. By late afternoon on May 4th, central Kansas had assembled the ingredients that violent tornadoes need. Near the ground, the air had turned warm and humid. Higher in the atmosphere, winds were changing direction and increasing in speed. That combination created strong wind shear, the ingredient that helps thunderstorms begin rotating. There was also abundant instability, meaning the warm air near the surface was eager to rise through the cooler air above. At first, the storms that developed did not look historic. Some tornadoes elsewhere were weak and short-lived, reinforcing the belief that the setup had not fully come together yet. But after sunset, another ingredient surged into place. The low-level jet, a fast river of air, a few thousand feet above the ground, that often intensifies at night. As those winds strengthened, they fed extra moisture, energy, and spin into the storms. What looked incomplete in the afternoon became dangerous by evening, and one supercell over western Kansas began organizing itself into the kind of long-lived rotating storm capable of producing a violent long-track tornado. For the people of Greensburg, the science was invisible. They did not see wind shear instability or a strengthening low-level jet. They saw a spring evening in Kansas, then a growing sense that something had gone badly wrong. Inside weather offices and local television stations, meteorologists were watching radar signatures become more alarming by the minute. Storm spotters and chasers were relaying real-time reports stressing that this was no ordinary tornado. On radar, the storm displayed a clear hook echo and extreme rotational velocity, the kind of signature that signals a violent tornado capable of catastrophic damage. At 9:19 p.m., the National Weather Service issued a tornado emergency for Kiowa County, including Greensburg. That phrase matters. A tornado warning means danger is possible. A tornado emergency is reserved for the worst situations, when a confirmed tornado is threatening lives on a catastrophic scale. So while professionals tracked the storm from screens and highways, families in Greensburg were making split-second decisions, underground in bathrooms, in basements, in closets, anywhere that might hold. Some were listening to television coverage. Some were following warnings passed through the community. Some simply knew they had seconds left. That is what makes this more than a weather story. It is a story of ordinary people forced into life or death choices, while an almost town-wide tornado closed in on them. The storm that would destroy Greensburg did not begin as a single perfect wedge tornado. It evolved. As the evening progressed, the supercell began producing small, weak tornadoes near its updraft. These early spin-ups were short-lived, but they were a warning that the environment had become primed for something much worse. The atmosphere was now fully energized. Wind shear was strong. The low-level jet had intensified, and the storm was no longer struggling to organize. It was feeding. Then the supercell tightened. Smaller rotations merged back into the main circulation, helping the storm transition into a cyclic supercell, a type of storm capable of repeatedly regenerating and producing multiple tornadoes over time. One dominant rotation emerged and began moving in a more sustained path. As it tracked along U.S. Route 183, it strengthened rapidly. Then came an ominous shift. The tornado briefly moved west in what meteorologists described as deviant motion, a departure from the path normally expected relative to the parent storm. Often, odd movement can signal disruption or weakening. Here it meant no such thing. The tornado intensified and placed Greensburg directly in its path. Storm spotters urgently relayed what they were seeing. Meteorologists on television emphasized the danger. Radar data showed a well-defined hook echo and violent rotation. The message was becoming unmistakable. This was no routine tornado warning scenario. This was a catastrophic strike about to happen. At 9:45 p.m., the tornado engulfed Greensburg. With winds estimated near 205 miles per hour and a width approaching 2 miles, the circulation covered almost the entire town. This is what made the event uniquely devastating. Most tornadoes carve a corridor through part of a community. The Greensburg tornado was so wide that nearly every structure in town experienced the core of the damage. Even homes left standing were often structurally compromised. After tearing through Greensburg, the tornado continued, then began to lose inflow, and eventually dissipated. But the parent supercell was still not done. Over the following hours, it would produce 11 additional tornadoes, including several other strong long-track tornadoes, proving just how persistent and dangerous a cyclic supercell can be. When survey teams entered Greensburg, they found destruction severe enough to settle the rating quickly. Some structures had been obliterated so completely that only bare foundations remained. The conclusion was clear: this was an EF5, the highest category on the scale, and the first EF5 ever assigned under the new enhanced Fujita system. The town had been devastated on a nearly unimaginable level. Roughly 95% of Greensburg was destroyed. 11 people were killed. More than 60 were injured. But those numbers also reveal something else. The death toll, tragic as it was, could have been much worse. The warnings mattered. The tornado emergency mattered. The work of meteorologists, broadcasters, storm spotters, and emergency communication mattered. And the decisions made by residents to take shelter, often with only minutes to spare, saved lives. Every statistic in this disaster represents a real person, a real family, and a real absence that remained long after the debris was cleared. Greensburg was not just struck by a violent tornado. It was forced to count its survival one household at a time. Greensburg's legacy is not only destruction, it is instruction. This tornado showed how quickly the atmosphere can outrun expectations. A day that appeared less favorable in the morning became historic by night. The lesson is not that forecasts failed. It is that severe weather environments can evolve fast, and small differences in timing can separate an ordinary outbreak from a catastrophe. The storm also demonstrated the power of a cyclic supercell. This was not a single burst of violence from a collapsing thunderstorm. It was a sustained, highly organized machine capable of regenerating rotation and producing tornado after tornado across the plains. Greensburg became a textbook example of why certain storm structures demand immediate respect. And there is a human lesson as well. Preparation matters before the warning is issued. Communication matters when seconds count. Construction choices matter after the rebuilding begins. In the aftermath, many families left, but others chose to rebuild smarter and stronger, turning Greensburg into both a memorial and a model of resilience. That is why this story endures. Not because one town was destroyed, but because one night revealed the full chain of vulnerability and survival. The atmosphere, the forecast, the warning, the shelter, the damage, and the decision to rebuild. We cannot stop tornadoes, but Greensburg proved that knowledge, readiness, and fast action can change how many people live to see the morning.